Thanks and hello student. My name is Ashok Sijala. In this session, we learn the merge sort in data structure. So let us start. First, I share my laptop screen and fix the position here so you can watch better way my video lecture. And here, I first cover the theory part in my book in data structure using C language. So here, that is chapter number 3 on 3.4, point number 4, merge sort. So merge sort means combining two shorted list into one shorted list. Yes. So that is a first condition is that two shorted lists are compared. So if not provide the shorted list, so first we can shorted any previous technique like selection short, insertion or bubble short, and then you can compare and then merge. So smaller of both the element is then short in the third array. The shorted is complete when all the elements from both sides are proper placed in the third array, and we can understand this concept with help of below figure. So you can look here. So that is a x and y, and you can look here. I take the shorted that is a both list, both array x and y, and we can take to z. So how to compare? Yes, here first 0 and here y 0. So 4 and 5. So 4 is smaller value, so we can take in the z as 0 index. Then here index is plus plus, so here 0 and 1 index compare. So here we can say that 5 and 7. So 5 is smaller, so that you can take here. Here index plus plus. So 8 and 7. So 7 is compared to here. And now index come to here in y. And that is a x is again that is a 9. So 9 and 10. So here now you can look is a 9. Index is plus plus. So 11 and 10. So 10 is come to here. So I take that type of element, one from X and one from Y element, that type of element. You can take any element to yourself. Yes. Now 11 and that 13 compare. So 11 come to here, index is plus plus. And now 15 to 13. So 13 to here. And now here that is a, we can say that 15 and 16. So again, yes, that is a come as 15 element. And you can look now here comparison is complete, but one element is remaining. So that is, we can define the logic. So now there is no any comparison, only one element of x or other y is remaining at the last comparison. So we can take that type of separate value for this x array or this y array. So both we can, so there are, we can take three value. So main comparison value, and at the last in here, if possibility any element remaining at last element, or here remaining at the last element. So you can take any element here in this example in y, that is last element is remaining. So that we have to take in the z. So now you can look that is a shorted. So that is merge sort, and that I cover the comparison, that is algorithm, and then advantages. So it is a better sorting technique or faster, yes, compared to selection or bubble or insertion. That is a faster sorting technique. This sorting technique is handle large list, yes, and disadvantage in this sorting technique require two memory compared to other sorted technique, because there is a large list and two compare list. At least two sorted list require to implement the sorting, because we have to first sort and then I cover the that program. Yes, so you can look here, that is a main while loop comparison, and one element from x or y that remaining we can take that while loop. And sorting, yes, you can here that I take selection sort, you can take anyone. And then here input and output, and here you can say that here that is a algorithm, and then quick sort is start. So now yes, I implement the program and I open the turbo C++, so we can take the program in this session how it's work. So yes, I open the turbo C++, and yes, that not, yes, now open. So Alt F and taking new file, and here our goal, write a program. Yes, that is a program to perform merge short. Yes, I take that type. Uh, so that is our definition. Or we can say that implement the merge short. That type of you can also write. You have to implement. And now first I include to our header file. So that is a require stdio.h, and then we can say that our default, so that is means two header file conio and standard input output and console input output. And now we can use directly in that dynamic array, so that is a alloc.h, malloc and free function we have to use. So now in global declaration, so that is a document section, that is a link section, and then declaration section. We can say that we can declare two user defined function UDF. So that is a merge. Yes, that and declaration time there is no required to variable name. So first that is a asterisk. We can pass the pointer and that size. So first array we have to pass, that is merge short, and then second that pointer and that size, and now third, so actual we can pass the three array, so two to our array, and third is a we can merge in the third array. So actual require the three one-dimensional array. So that is a first UTF. And now second, so we can take as short, if not a short at least provide, so we can take as a short. So any short in previously like selection, bubble or insertion. But you can say that selection short is simple, so you can use anyone, there is no problem. So that is all I take as that fourth video lecture in data structure, so you can watch in my previous selection short, then insertion short, bubble short, so that I take. And now here we can pass, yes, first that is our pointer asterisk, and then so yes, in your mind question why here no require any variable name, you can provide but no require, so that is optional. In declaration time, definition time we can must be provide, but that is a declaration, that is a three-part declaration. Then inside the main we have to call, and outside main we can write the definition of UDF. So that is I declare in advance. Now our void main, so now our first that is a declare to variable, so that is a asterisk x, because we can take as pointer and we can use, yes, malloc and calloc, yes, you can any choice. And here that is a three pointer x, y and z, and then n1 and n2, that is our size, and then I variable. So that is our index, we have to say that means our for loop we have to start, because that is one array. So clear the screen, and now first we can enter the size. Yes, how many size? So enter, yes, in between double quotes. So enter, yes, you can say that x, or first, yes, you can write on x array. So here that is a first or x array size. So that is our name of array is a x, and we can scan the size of array. So that percentage d and m percent n1. So n1 means n2 is size of y, and n1 is size of x. So that is suitable, you can give the message, and one blank and column that you can provide, so that separation. Yes, sir. Now we can use x, and that is you have to know that we can take as malloc, and then we can take as n1 and multiply size of, and that is a integer data type. But malloc, that return data type is a void pointer. So here we can must be as typecasting as integer pointer, because array that pointer data type is integer. So here is integer, and here size of, that is a number of bytes, size of is a operator, and return the byte in, so 2 byte integer required. So here which type of pointer you can take that data type like integer. So here I take as integer type casting, and here float, so float, double, so double, character, so character. So that type of data type you have to take. now. So memory allocation is perfectly, and now we can scan. So yes, we can say that message suitable enter x array elements. Yes, so that type of message, and now we can take as for loop. So that is a perfectly, and here we can provide the slash n, and now I equal to that is a 0, I less than n 1, and I plus plus. So and taking opening closing brace, and we can scan first print. Yes, I always scan as the index with index and print also index. So that percentage d, so which element store is where in which index we can find out. So now scan a function. So percentage d, then ampersand, and that is a x of I. So yes, that is a scan. And now what to do? So here yes, we can scan, and if you print that also you can print, but here that not required. So now what to do? So yes, that is the same process in second, means the y, that so I copy this part because that is a two one dimensional array, then and then we can short, and that is a compulsory shorted list. So we can declare one UDF short. Yes, any short, any one over previously short technique. So here I take the fourth short technique, and that is a merge short. So very interesting and very faster technique, and how we can apply to our logic. So you can look here, you can also give the second array size, but here I give the enter y array size, and here n2, yes, just I change. So all the, and now here I take as y, and here n2. Yes, so and now we can also scan y, and here I change the n2, and here also we can change modify. So it is a y, and here also y. So two, we can that user can short or unshort, we cannot give any message. So if unshorted, so first we can pass to merge short, and then we can call the short. So nesting UDF call other UDF, that is in my logic I cover. So nesting one UDF call to other UDF. So first yes, we can take the memory of z. So yes, here first we can provide the memory allocation z. So that is a we can cover. Yes, here I directly typecasting, and now take as malloc, and then how size. Yes, that is a z array size. So both that size of x and y. So that is I multiplication, means parenthesis, and 1 plus and 2, that number of size is possibility, because we can merge, and then that is a size of integer. So that is a perfectly. So look, now that is a integer data type. So yes, some so n1 and n2, so we can take n1 for x, that size of, here we can scan, and here n2 we have to scan. So that number of element is possible in third that z array. So I provide the memory allocation, and now what to do? So yes, here we can pass, yes, that I call the merge, that is our UDF, and I call and pass four argument. You can look here. So that is a first is pointer, and then size, then pointer, and that size, and third our Z. So that is a X. Yes, now you can understand, and one, then Y, that is our, so we can pass only, that is a address, because that is a pointer. Pointer always take the reference pointer, so that is a take the address of other variables. So here we can pass the pointer, and that handler is also pointer. So yes, that is a size of n2, and also pass the z. So actual 3, that is xyz, and n1 and n2, that is a size. And now yes, here we can print. Yes, you can look here. Now we can shorted in the merge short, but we can print in the main. That is only possible using the pointer. So that is a merge. Yes, array. Yes, merge array elements. So after that is shorted. So merge array elements, that type of, or we can say that shorted. Yes, let us check. So I provide /n and just take the for loop. So I equal to 0. Yes, then I less than. Yes, how many size? So again parenthesis and 1 and n2, that number of possibility, and I plus plus. So yes, that is a we have to print. And if you print the index, that is also possibility. So yes, I print tab function. Yes, I give the tab. So formatting is very important. So here that is a, we can say that Z, yes, percentage T, and that is very long list. So first I print index and then I also remove after, you can print, and then I and that Z of I, and we can provide the here also /n. So now perfectly, and then get ch. So that is a main our that all yes, I first save this file. So we can say that merge, so that file name merge and short. So 3 letter MER. Yes, and underscore is also count. So dot C. So merge short, that I give the name. So MER only, and you can also use merg merge, and that also possible file name. So maximum 8 character is required. So yes, look, yes, here our main function, and main is a user defined function. Yes, some student that getting the main is a inbuilt function, but that not true. So main is a also user defined. So there are two type of main category of function, uh, inbuilt function and user defined function. So that is a main category too, and user defined then again subcategory. So there are 5 subcategory. So you can watch in my C language that all video user defined function in C language. So you can get the idea. So now what to do? So yes, our main function is complete. Now what to do? So we can definition of that is a return is a void. You can say that here we cannot return any value merge short, but after all we can also print in the main, that is a Z. So how it's possible? So that is only happen in the pointer reference variable. So that is a pointer indirectly. So indirectly that print to a requirement element. So merge, yes, that is our UDF, and we can write the definition. So definition time we can take the variable name. So here I use as same. Yes, there is no problem. X I use, and then same I give the name S1 size one. You can also use N1, but there is no problem. So that is a perfectly. Now what to do? So comma and then asterisk y, then again comma and s2. So you can also use n1 n2. So that is my goal. You can also take the same variable and also take the other variable, means change the variable name. That is, here we can also use xyz. So here also we can use xyz, and here n1 and n2, but here s1 and s2. So that is, I also give the idea. You can also give the same variable name udf and also give the different variable name, that is possible in UDF. So now that is last asterisk Z. So perfectly. Now what to do? So first we can take declare some, that is a I equal to 0. Then there are 3 index. Yes, because that is a 3 array, X, Y, and Z. So X index for X, I index for X, then now J index for Y, and and K index for Z. So we can initialize index start with 0. So all initialize is 0. Yes, that perfectly. Now what to do? So we can call, yes, I previously told you, first we can shorted, that is a merge short is a must be. Yes, merge short is a must be to shorted list. If user not enter the shorted list, so what happen? So we can call the short. Yes, that is a, again we can write one UDF and calling the nesting. So first merge short call, and we can pass this array for shorting and then comparison. So here x, and that is we can pass to that size s1. Now that name is s1, and then I again call the short and pass to y and s2. So that is a first we can write the our second UDF, and that is a short. So any short you can use technique, and that is I take here different name p pointer, and that size, so that is I take as n. Yes, so we can take as here shorting. And yes, you can look here, I also if global declare I, so here I also use, and here in this UDF also use, but here index start with 0, and short function also use the I index or any you can. So here there are two I and j, because we have to take as a shorting selection short or any shorting technique. And one temp variable you have to know, shorting we can take as a comparisons swap logic, so you have to know. And now I equal to 0, then I less than s1, or not n. Yes, we have to take as s1. Here s1 is also copy, and s2 is also copy, and x first is come to here in p, and y is also come to p. So only one UDF short to two over list x and y array. And then yes, first loop, now inner loop. So yes, here you have to know we can take as selection sort, so n minus 1. So one extra round we have to not count in outer loop. So four time that outer loop is, that is outer loop, and that is inner loop. So after four round complete our outer loop, that is our list is shorted, so no extra, we can n minus 1. So that you can also take as watch window and observe how it possibility. So you can watch in my selection short technique in my YouTube channel. Yes, now what to do? So yes, j, yes, you have to know I plus 1, and yes again that is a j, you have to know j less than n and j plus plus. So now we can take yes if condition. So that is a if, and p of I, yes, here that is a, we can say that greater than, yes, so that is a p of j, yes, p of j. And now we can take three statement of swap. So first we can temp, and p of I, and then p of I is free, means assigned to temp variable, and now p of j assigned to p of I, and now p of j is free. So means free means that value to assign to other variable. So now we can assign to temp value. So that is a swap. So you can look now our UDF is complete. So yes, I take that is a one is remaining. So here and now here, yes, complete. So yes, any one, yes, here one extra. So yes, that taking error. So I remove this, yes, no any extra space, yes, I blank, all remove. So our one UDF, yes, short. So first we can short and then comparison. So that is a condition of the merge short. Two shorted list is required. So we can pass X first, then Y. If a user not provide shorted list, so we can taking first short, and then we can start to our main, and that is a you have to know that is our merge short. So two shorted list is required, must be. Yes, so here we can first that is a uh, pass to one x to our short element, and that other to y. So one by one we have to take. So now yes, complete. So here what to do? So yes, here we can start to our main logic. So we can take as while loop. Yes, that is a better. Now here no required to for loop. So first we can take as comparison. So yes, I less than not equal to S1, and then logical or operator. So j less than S2. So that is our main for while loop. And now what to do? So yes, here first I take as if condition. So yes, you have to take. Now what to do? So yes, here we can, yes, perfectly. So here we can comparison is start. So x of I, yes, so we can x I index is x, j index for y, and k index for z. That is our logic. And now we can x of less than, or also we can take as equal, and y of j. Yes, that if possibility means that is 2 less than. So what to do? So yes, I take as k, and then I assign to, that is a x of I. So here we can take as x of I. And now k plus plus, then I plus plus. So first I take that type of, and now in else part same, opening closing brace. And now what to do? So if k, yes, that is a k plus plus, uh, and then y of j, and then again k plus plus, and then j plus plus. So that perfectly. And now what to do? So here, if any list is complete, so we can take like I equal to S1, or logical or operator. So again, I use logical or, and J equal to S2, that number of index. So we can look, that is a break. So while loop is break. Yes, you have to know what is the use of break keyword. So any, in my figure, you have to know that is a, we can compare X and Y. So any last element that is a complete, so I equal to S1 or J equal to S1. So any one is complete, we can break our while loop. Yes, that is our goal. So now perfectly. So what to do? So yes, now yes, I previously told you. So that is our main while loop. Yes, you can look here. So that is a, we can compare if x of I is less than y of j. So we can copy the z of k to x of I element. And if that is a x element is greater than, so we can copy the y element. And both that index I equal to S1, that is N1 is that size of X, and S2 is size of Y. So any one is complete, so we can break these two. And both index you can look, K plus plus and I plus plus here, again K plus plus and J plus plus. So yes, now perfect. And now if last element remaining for from X, otherwise remaining in the Y, so what to do? So again we can take as same, that is a, I previously told you we can take actually 3 while loop. So yes, I less than S1. So what to do? So same logic we have to take. So yes, x of that is a k, and can take x of that is a I, and then again k plus plus, same in our that is I plus plus. And then what to do? So that is a last element if remaining in x or remaining in the y. So same, j less than s2. So that is a, only one element we can take this while loop. So we can take k and assign to y of j, and then here again k plus plus, otherwise j plus plus. So that I take first large, means some statement is not required to here. I know very well, because but I first understand to you. So yes, all our logic is perfectly. So actual 3 while loop. So I previously comparison, so both lists. So we can also take as watch window, but that process is very long because that is a merge sort. So now, yes, our all logic is perfectly. Now I compile, yes, any error, no error, yes, perfectly. So let us take, I give the our input and output, and that I take from my book. Yes, so very easily we have to take as shorted element. So yes, I switch over, and so first I take as window key press, so minimize, and yes, I So you can look here. So my book, yes, that is a year open. So you can look here. We can take as input and output process. So yes, I give the randomly. You can look here. That is a first at input. So enter size 5, and that is a 5, 15, 9, 8, and 11. So yes, I write somewhere this element, so we can enter this type of element. So first is 5, then 15, 9, 8, and 11. That is first our, and second, that is our not sorted list I enter. So 7, 4, 10, 16, and 13. That is our second. Yes, I write my not, and now open again editor, and that is we can. So yes, now perfectly. So yes, any, okay. So I have to, so compile, yes, and now run. So you can look, enter X size means X array size. So I enter 5, and then yes, you can look, that is index. So I enter, that is a first we can enter 5, yes, very careful, then 15, yes, that is not sorted list, then 9, yes, then 8, yes, perfectly, and now 11. So that is our first input. Now you can look, that is only 5 size, again 5 size, and that is a Y. So it is a perfectly, you can, I give the slash n, so x of I 0 index, that so now I enter 7, then 4, yes, then 10, yes, then I enter key press, and 16, yes, and then 13. So perfectly, and now I enter. So you can look here, merge short elements. So 4, 5, 7, 8, 9, 10, 11, 13, 15, and 16. Yes, perfectly, our logic is perfect. So yes, you can also print in, that is a vertical, but you can also print in horizontal. But horizontal you cannot print the index. So I also give that technique. So yes, I come back to our editor. So our logic is perfect. And now what to do? So here in print, that is a main. So you can look here. So here I provide the slash t and remove this index. So we can print without index, and let us check. So I compile, yes, there is no any error. And now again I give the 5 and same element. Yes, I remember 5, then 15, then 9, 8, and 11. Yes, that is our X. Now 5 is a Y. So 7, 4, yes, that is 10, yes, now, and 16, and last is 13. So you can look now. So 4, 5, 7, 8, 9, 10, 11, 13, 15, 16. So that is a 10 element. Yes, 5 plus 5. So that is a Z element. And you can also print the index. There is no problem. And we can provide the slash T. So that is 5 blank space, one element between two elements. So yes, perfectly. So let us check. Yes, you have to also print here if index is also possibility. There is no problem. And here we can remove some extra. So that is a good programmer sign. If unnecessary statement we can remove. So yes, actually I remove the these two statement is not required. These two statement is not required. So 2 plus 2 4. And here that is a, we can also, that is a x, and here that is I. Yes, here also we can plus plus, but that is a already I is plus plus, so that not required. So yes, how to possible we can plus, where we have to plus plus. So yes, that is 8 statement we can remove. So how we can remove? Yes, let us check. So yes, that is a prefix and postfix you have to know. So that is a two statement we can remove. So in if condition only one statement, and one statement, that is rules that not provide the opening and closing brace. So there are four statement removed to here, and four statement in the else part. So that is a very benefit. And here also while loop there is a four statement. So opening closing brace is also one consider as a one statement in our compiler. So that is also some time consuming. So and same, so here actual 4 4, so 8, and here 4 4. So we can remove the 16 extra that statement in our this logic. So I previously not taking short logic. Now I think you have to understand, so I give the short. So I remove this brace and also remove this brace. So how? So I remove this k plus plus and I plus plus. So how we can plus plus? Yes, directly in index. So I k plus plus and I plus plus. So that is very short. You can look very concise logic. I now also I remove this opening and closing brace. So once statement there is no require opening closing brace, and also remove these two statement. So why we can plus same. So yes, k plus plus and here k plus plus. So you can look. So we can remove actual 4 statement to here and 4 statement to here. So very short our while loop. You can look very concise, that known as concise or very short logic. And same from this while loop that not require this opening. So that is a rules, only one statement in decision statement. So if else is a decision statement, we can remove the opening closing brace, but two statement that is a compulsory. So you can also remember that rules. And here again k plus plus and then I plus plus. So we can remove again these two. So you can look only one in while loop and also these three. So actually we can remove the 16 unnecessary statement in our logic. So that is very short logic. You can look now. So I previously not write because that I can explain to you, so how you can concise your logic. So you can first try to reduce to your variable if necessary, then reduce to your statement, then decision statement, and then go in the loop. So that is a better or good programmer sign. So yes, that is also not burden to compiler to compile our program. So that is a very important. Yes, that is a like one formula. So you can reduce your variable statement, then decision statement and loop. So yes, I hope you can understand that is a merge sort logic, and we can directly we can short in the our merge sort UDF, but we can print in our main. You can look here, Z print in the main. So that are perfectly print because that is a pointer. And now again I print the index, so that is a perfectly. Yes, and provide here slash n, and here I provide the I. Yes, here comma, and now here no require to slash n, because here we can provide slash n. Okay, so and now yes, we can take how. So that is a we can take as a watch window, so you can understand better with this logic. So how it's shorting. So let us take, I press F5 and Alt W. So that is a watch window, and again Alt W and output window. So you can look here. So now how to set? Yes, here green selection, and I click the enter. So X of I, yes, and then that is a Y of J, yes, and then Z of that is a K. So yes, I directly not means scanning and that type of wasting our time. So directly start the watch window too. So what to do? So we can start the watch to directly in our merge. That is our main logic. So that is Alt Control F8 function. So that is a red line. So now I can directly run. So that is a waiting in this logic. We can watch observe in our watch window. So I Control F9. So our program is run, and I press means X, enter X array size. I give 5 and same element 5, then 15, then 9 and 8, and I think 11. Yes, again that is Z array. So 5, then 7. Yes, 4. Yes, 10 and 16 and 13. So now you can look our watch window. So that is a waiting, and I press yes Alt R. So that is a trace into F7 function key. we can line by line execute our program. So F7 function key, you can look. So yes, also we can print the index. So like I, then J, and then K. So all are garbage first. And I take this main over screen to some size is reduced. So yes, I some size bigger of our watch window. So we can observe all our variable. And also I take that output window to this size directly to here. So you can look here our scan to X and Y that we can observe directly see to here. And now we can start F7. So all ijk, that all garbage value is gone. You can look now. And then first X of I, that is our that I element I can show you. So that is a zero index. So that is go in the so nesting merge short that call the short, and that is any, that is selection short. So that is a P. Yes, now I also here write that is a P of I. Yes, that is P of I. Yes, that, and that is a P of means J. Yes, and also temp variable. So that is, I think, simple. You have to understand. So you can look, that is a shorting all element. So that is a not if condition is false. So that not yes, now again. So that element is swap. I not so wasting two times. So because that is a phi is small. So that comparison that all now again short. So you can look here. 8 is comparison to now 11. So yes, that is a greater than, so swap. Yes, that is a selection shot. Yes, first shot is complete. So I'm not wasting to time. Now again, why go into a shot, and that is a shorting. So you can take yourself. So you can look here. So 7 is comparison to that is not 4. So 7 and 4. So that is a yes, first our loop. So smallest element come to the our zero index. So that is a selection shot. I just pass out. So you can look here in watch window. So all element is compare one by one. And now that is a swap, and our short list is ready. So two shorted. Now I take in that how to watch window is work. So yes, you can look I less than, and yes, I remove that P. So very S1 is size of 5, and S2. So yes, S2. So S2. So that is the size of our N2. And ij I already write. So you can look here x of I and y of j. So that is a first, that is a shorting now. Yes, here not. So you can also print after before shorting here x and y. That is also possibility. So what is a comparison? So 4 and 5, zero index in x is a 5 and y is a 4. So you can look here 4, and here that directly 4 and 5. So that is a copy is not if condition is false, because that is a 5 here, and here is a 4, so less than. So yes, not condition is false, and then copy, so 4 copy in the z. So yes, that is a not I is a 0 and j is 1. So that if condition is not false means true. So that is false. And now while loop, yes, that is a true always. So yes, that what to do. So yes, now here that is a 5 and 7. So 5 is less. So if condition that true, and that if not true, while loop is again true. So yes, that is a now 8 and 7. You can look my figure in my book. So you can look same. So now come to the 7. That is a y element in the z. So now 8 and 10 is comparison. So you can look 8 is smaller than 10. So that if condition is true. So that continue process. Yes, now I can pass out. So that is a last element is remaining from X or Y. Let us check. I pass out. So yes, I think now here you can look S1, and that is a uh, S1 and S2. So here I and J, yes, you can look I less than. So now 11 and 13, yes, so that is a copy. And again that S1 is 5, but here I is 4 and J is 3. So if condition false, but Y is true. So again come to here. So 15 in 13, so 13 is copy. And now last one, yes, you can look here. One element is remaining from, yes, that is a y, because 16, now 15 is copy. And you can look now, I and j 4, 4. Now last time, so 15 and 16, so else part is execute, or if condition is execute, true, and that is 15 copy into our z, and 16 is remaining. You can look, so that is I can take, why we can take these two extra while loop, same logic. You can look here, we can write that time of just we can take a separate while loop. So perfectly. Now you can look, I is 5 and S1 is 5. So anyone is true because that is a or, and break, while loop is now break. So that terminate. And here you can look, I less than S1. Yes, that is not equal sign. So that is a X, not any element is remaining. But second while loop is execute, because why? 16 element, one element. So I take a watch window only, that how we can take these two extra while loops. So any one element from here, or X or Y, so that copy and last copy in the third array. So you can look, that condition is true because J is 4 and S2 is 5. So one time this loop is execute, you can look. And now 16, last element from Y, that is remaining to our copy in the third array. So that is a plus plus, and that is a 16 element copy to our third element. Yes, and now you can look that while loop is a is 5 and s2 is 5, so that is also false. And come to main, and now that printing is start one by one. You can look in our yes, I give not a percentage sign. Yes, that is a remaining, so not any print. You can look here. So yes, that is a index print, but I forget to 1% D. So yes, how to remove this red line? So Control F8, and now first I provide here, that is a percentage D is remaining. So our element is not print. So now I run directly, and 5, yes, that already perfectly work. We can already see. So yes, 5 and 15, and I think 9 and 8 and 11, that is our X. Now why I take my book that element, and 5 you can to your choice any element. So 7, then 4, then 10, and then 16, and then 13. So you can look, that is perfectly, our logic is perfectly. So 4, 5, 7, 8, 9, 10, 11, 13, 15, and 16. So how do I take watch window and output? So you can observe any last element remaining, that is a copy, either this while loop or either this while loop. Remaining which X remaining, or X element remaining in copy to Y, or Z, or Y element copy into remaining in Z, our third array. So that is your very important question from student side. Why, sir, we can take this while loop? Because any one element remaining, we can do this process, either of X element remain, or either as a Y element remaining. So now I hope you can understand. Yes, very important. And that is a merge short. We can so many time to spend this logic. So that is very important technique in sorting in data structure. So any question regarding this logic, you can write in comment section. I give the definitely to answer to you. So write this code to your notebooks, and now I close Alt F3 function key. So yes, I close this file and watch window, output window, and quit. So yes, I also close this Word file. Yes, that is my on save. Just subscribe my channel Ashok C. Jalakani. Press the bell icon to never miss any update. And thanks for your watching, supporting, and sharing my video lecture. Hare Krishna.